Virtualization. Well, that's what the topic of this conference is about. And Rick, we just heard you in a panel from Comcast Bell Canada talk about this. And one thing you emphasized was it's an opportunity, it seems, to move kind of that attack vector away from the customer. What does that mean?
Well, a virtual network topology, really what it does is it creates a virtual networking layer on top of the existing physical network. So it exists with the existing infrastructure. It allows applications to run without any changes to their protocols. And if you think about legacy protocols, they were really written to be cooperative and trusting, which works very, very well on a private trusted network. It doesn't work so well on a public internet where adversaries and hackers may be trying to attack you. And what the virtual networking layer can do is it can ensure that users, appliances, devices, and flows are authenticated and authorized before they gain access to the network. And what that does is it moves the attack surface away from the customer and into the cloud, what we call network platform as a service. And so then what an attacker is doing is if they're trying to do a DDoS attack or other type of attack, they're attacking the network platform. And then if there is an attack, we detect it and we simply move around it. The end user, their servers or whatever data and devices they're trying to keep secure are never under attack.
Well, and that leads to a point or question of by having that focus on just the network part, does that make the task a little bit easier in the sense you can focus your resources there, or?
Right, you can definitely focus your resources on your specific business and your specific value add. It also greatly simplifies the process of adding new applications or new services. The way it's done today, you might have an application team that's responsible for bringing up a new application, perhaps in the cloud, perhaps on premise. Then there's another team that has to manage all the security, perimeter defense, firewall settings, port openings, protocol rules, all those things. What you do with a virtual network is you just set up rules for what machines are allowed to access what resources, and then the virtual network just authenticates the request and then passes it on to the virtual network. Depending on how you set up the communication within the virtual network, for example, you can use strict UDP, which means you can have a legacy server running with a TCP. It's doing a listen, at a spot where normally an attacker would be able to run a port scan and find out, oh, these TCP ports are doing a listen and they're open, or these other ports are open. Now, instead, those servers can only exist on a private network, a private subnet, perhaps even 127.0.0.1, and the virtual network just authenticates the request, authorizes it, and then passes it into the local network after the security measures, the hashing, and the authentication has been done.
And it seems like that's an important thing for this hybrid world we're going to live in with purpose-built and software-defined, right?
Well, as we move forward, and you just about every day now you hear about new attacks. I think there was one recently on the San Francisco Muni. There was a famous DVR botnet attack that was used to redirect and instrument a DDoS attack. What this does, like I said, is it ensures that all the requests are authenticated before they get to the end user. In the case of the Muni attack, those kiosks would have never been discoverable by the malware, and it's very difficult to attack what you can't see. And so I think it's time to have a fundamental shift in how we view the network, and we view the security as being built into the network and have the network platform provide the security, as opposed to having bolt-on technologies like firewalls and packet inspection, etc., providing the security.
Well, and I suppose, too, the applications then, if you're developing the applications, you can bake the security in at that application layer as well, right?
You can bake it into the application layer. You can build this stuff in through SDKs. You can install it on any laptop, PC, Linux variant, or you can do it as a carrier, in an ecosystem for a carrier. So it's a software-defined solution that allows you to put the security wherever your particular needs dictate for it to be. I like the idea of a software-defined perimeter, of identity-based networking, of moving the attack vector away from the customer into the cloud, simply because it's easier to detect when a resource is under attack and then simply move away from it.
Well, and it seemed like that was a big theme as well. This whole idea of automatically detecting when the attack's happening, right?
Right. That's another challenge in security. We were talking about the automation of the provisioning and the operations aspect of it, and that's a key for automation. But security these days, these attacks happen so quickly that the response has to be in real time. If you rely on a human being to detect that an attack has occurred and then apply a consequent action to it, it's oftentimes too late. What we want is for the network to automatically detect it, shut down the attack, apply a consequent action if needed, log the activity, and alert the user. Because by the time the user even gets around to analyzing the logs and what happened during the attack, it's probably over.
Now, let's talk a little bit about dispersive technologies. I know you have an alternative to VPN, and it relies on this idea of virtualization, right? Why don't you explain that in a few words?
Well, our core technology is really what we call the dispersive virtual network. And it has many, many use cases. VPN replacement is one of the use cases. I think if you look at traditional attacks, VPN is a common attack vector where people will just, social engineer the username and password, because those VPN tunnels are just based on username and password, and they can be brute forced. Multi-factor authentication, username and password can be used as multi-factor authentication, but it's insufficient to do the authentication piece. And if you look at tunneling technologies, encrypted tunnel technologies like VPN, there's a couple of weaknesses. One is the username password weakness. The other is once you break into the network, you're essentially in the multicast domain. You can discover anything, you can talk to anything, and if you install malware or get access, the resources that you infect then can talk out to the open internet. In many cases, secure devices, especially when you start talking about IoT and other functions that provide critical business value, there's no reason for those to really ever talk to the outside internet. And if you detect that they are trying to initiate communication to the public internet, it's often a sign that there is an attack in progress.
Mm-hmm. And so I understand you kind of break up the streams in some way to get back to the...
Well, we break up the streams for a number of reasons. First of all, it makes collecting the data and sniffing the data that much harder. We roll keys and we use different encryption techniques and inject red herring traffic so that if an adversary is trying to implement a man-in-the-middle attack, it's that much more difficult. Part of security is high availability. A DDoS attack is really aimed at eliminating the availability of a server or other resource. And by splitting everything around, we can provide high availability and performance so that if we detect an attack at a particular link of the network or a particular point in the network, or if an attacker attempts to bring down a single point of bandwidth, we simply detect it and we move around it. If you think about the way that legacy protocols work, they first attempt to find a single path through the network, and then they use that single path for the duration of the session. If there's congestion, the session continues in a degraded manner. If there's a failure, usually that failure will promote all the way up to the application. The application will have to either handle that and restart or begin from the beginning of the transfer. What we do is we automatically detect those errors, we move around them, and the only time an error is promoted up to the application is if there is no connection through the network at all. If there's congestion, we move around it.
So from a service provider perspective, what do they need as far as endpoints to make something like this work?
Well, it's a topology network. So essentially you put the components of the DVN to instrument the control plane, the configuration plane, and the data plane into the core of the network. And then there's various options for how far you extend that, if you extend it to a POP or all the way to the end customer based on the end customer needs and the use case in question. It's a technology that runs on the existing physical network. It's really an overlay network, a virtual overlay technology that enables new and powerful services.
Excellent. Well, Rick, I really appreciate your time.
Well, thank you.